Good afternoon, everyone. Am I audible? Or my voice is low?
Yes, sir.
Okay. So we're going to start with differential equations. Are you able to see the screen? Able to see the screen, right? Okay. Let's start with the chapter differential equation. Okay. So differential derivatives, okay, are called as a differential. This symbol generally d by dx or d by dy or d by dz. Generally, this symbol is called as a differential. So, equation which is made up of a differential will be called as a differential equation. Say, for example, if I'm writing something like this, x cube dy by dx plus xy plus 5 equal to 0. So, up till now, the equations what we have seen was in the terms of x and y's only, or maybe z. But we did not have any equation in forms of like this. Suppose I am writing something like this: x square d2y by dx square plus xy dy by dx plus 6 equal to 0. So here also I am having this term dy by dx. So whenever in the equation you have the term where you are getting differentials, or in other words derivatives, then the equations are called as differential equations. I'm using the short form DE for a differential equation. This is a very important chapter, not only from mathematics point of view, but also from understanding of physics and engineering. Okay, we know derivative gives us a rate. So when we are studying in 12th standard, we take a lot of assumptions and then we derive in physics. But as you're going to go ahead, okay, in the journey of your graduation, you are going to remove a lot of assumptions and you will go towards much more realistic world. So that time you'll realize that nature talks with us in the form of differential equations and not those simple equations the way which you have studied in your 12th standard. Most of the times the nature will always, or the natural phenomena, whenever you try to describe them removing assumptions, you are going to get differential equations. Okay, so this chapter is okay very important from point of view of your JEE as well as from the future perspective. So let's start with this. So we'll start with the basics. A differential equation will have order and it is going to have a degree. Okay. So what do you mean by order of a differential equation? So order is nothing but how many times derivative you have taken. And degree will be nothing but power or index of highest order. Let us say take the same example which I have written over here. Okay, same equation x cube say d2y by dx square plus x dy by dx plus xy plus 5 equal to 0. So when I have written something like this, d2y by dx square, it means I have to take derivative two times. When I am writing dy by dx, it means I have to take derivative only once. So this is the highest order throughout the equation. The highest order of derivative is this. So this becomes the order of the equation, which is 2 in this case. Then what you have to see? You have to see the power of that. You have to see the power of this. So power of this is 1. So the degree of this equation will be 1. Okay, order is 2 and degree is 1. Okay, let me give one more example. Uh, Please take the screenshot of this. Please take the screenshot of this. Okay, let's take one more example to understand degree and order. So I have this equation something like this: x d cube y by dx cube raised to 5 plus x d2y by dx square raised to 6 plus y is equals to 0. So I have an equation something like this. So now highest order is this, where you have to take derivatives 3 times. So this becomes your order. So I'll write order is 3. Then you will have to see degree also of the highest order derivative only. So highest order derivative is this and the power is this. So degree will be 5 and not this. You should not see the highest power. You should see the highest order of derivative. And then you will have to see the power of that highest derivative. Okay, so highest order was 3 and its power was 5. So order is 3 and degree is 5. So important point to note about order and degree is that these are always integral values. Means this should always be integers. Fractional is not allowed. They should always be integers. Let us try to understand from one more example. So I have this, I have to find out, okay, degree of this. So square root of 1 plus dy by dx. Oh, sorry. It is 1 plus 1 by dy by dx, the whole square is equals to d2y by dx square raised to 3 by 2. Now I need to find out the order and degree of this differential equation. Now what I have written, it should be integers only. So this is not allowed. This is not allowed because this is not an integer, it is a fraction. So what I will have to do, I will have to square both the sides so that this 2, okay, can be removed so that I can get an integer. So I will do squaring both the sides. So in squaring both the sides, this square root will go away and I will get 1 plus 1 upon dy by dx, the whole square is equals to d2y by dx square raised to 3. Okay, which can be written as again. So here I got, this is my highest order, that is I have to take derivative 2 times, and the power of that term is how much? 3. So degree is how much? 3. So order of this given equation is 2 and degree is 3. Okay, I hope you have understood. So this is the basic. So every differential equation is going to have order and degree. See, in algebra, when we have studied the equations, so the variables will have power. So we used to only talk about power. So quadratic equation means power 2, cubic equations mean power 3. If power is more than 3, okay, then those are polynomials. If the power is 1, it is linear equation. We only used to concentrate on power, but once we come into differential equation, okay, not only power, order is also required and degree is also required. Now, what's in your syllabus? Okay, your entire syllabus is going to have numericals pertaining to the entire, almost the entire one, order 1 and degree 1. The numericals which you have to solve generally are of order 1 and degree 1. Okay, where you have to find out the solutions of the equations. Single degree, single order, first order, single degree equations only you have in your syllabus. See, this differential equation is a very big topic. Therefore, when you go in your engineering, one mathematics will entirely have ordinary differential equation. Second maths will have partial differential equations. So in one semester you will get ordinary differential equations, in another semester you are going to get partial differential equations. So understand, this is a very wide topic, and that is why you are having only this in your 12th standard syllabus. If the order of the equation increases, degree of the order equation increases, then the solution and solving method also changes. Hence, in your syllabus, you don't have all those. Okay? This is going to be a continuously occurring chapter. I hope you have understood degree and order. Take the screenshot of this. Okay. Okay. Let's move to the next topic. Formation of differential equations. So suppose I am given an equation and I want to find out a differential equation, or I want to form a differential equation. Then how should I form a differential equation? So very easy way is, your order of the differential equation will be equals to number of arbitrary constants. So if two constants are there, you have to take derivative twice. If one constant is there, then you have to take derivative only once. If three constants are there, then you have to take derivative thrice. Okay, and so on. So we have this equation as, say, y square is equals to 4ax. And what I want to do is, I need to form a differential equation of this. So how do you form a differential equation? We'll just take derivative with respect to x. So derivative of y square will be 2y dy by dx is equals to 4a. Derivative of 4ax will be 4a. I have to eliminate the, okay, arbitrary constant. Remember that. You will always need to eliminate the arbitrary constant. So from here, 2 2s are 2 1s are. So from here I'll get the value of a. Sorry, I have network issue. Till where you are able to hear or see, students? Students, till where you are able to hear or see, please tell me. Please reply me in chat at least. Till where you are able to hear me. Are you guys there online or no?
Yes, sir.
Till which point you are able to hear me? Okay, so from here I got the value of a as y by 2 dy by dx. I hope everyone is able to see the screen. So I'll put this equation number 2 into equation number 1. Therefore, I'll get y square is equals to 4 into a. The value of a is y by 2 dy by dx into this x. So 2 ones are 2 twos are, so I'll get y square is equals to 2y into x and dy by dx, which can further be written as 2xy dy by dx minus y square is equals to 0. So this is the required differential equation. Okay, so I wanted to form a differential equation. I was given equation of parabola and I wanted to form a differential equation, and I have successfully formed the differential equation. I hope you have understood. Let's move on to the next. Let us see one more. So here we have y is equals to a into e raised to 3x plus b into e raised to minus 3x. Now, how many arbitrary constants are there? 2. So I said the order of the differential equation will be equals to number of arbitrary constants. So this time there are 2 arbitrary constants. Therefore, I will have to take the derivative of this twice. Not only that, the constants also should not be there. So I have to take derivative twice. At the same time, I need to eliminate this constants also. Okay. So let's see how we do it. So we'll take the derivative of this. So derivative of this will give me dy by dx is equals to a into 3 into e raised to 3x plus b into minus 3 into e raised to minus 3x. I'll take derivative once more because 2 times I will have to take, so I'll give d2x by dx square is equals to 3a. Derivative of e raised to 3x will again be 3 into e raised to 3x plus minus 3b into derivative of e raised to minus 3x will again be minus 3 into e raised to minus 3x. So I'll get d2y by dx square is equals to 3 into 3, that is 9. Here also minus 3 into minus 3, that will again become plus 9. So I can take 9 as common. So a into e raised to 3x plus b into e raised to minus 3x. So if you see this is exactly the equation number 1. Therefore, instead of this, I'll put equation number 1 in equation number 2. Therefore, I'll get d2y by dx square is equals to 9. Instead of a 3 raised to x plus b 3 raised to minus x, I can write it as y. Therefore, I'll get d2y by dx square minus 9y equals to 0. So this is the required differential equation. So I was given by an equation and I wanted to form a differential equation. So I have successfully formed a differential equation as well as I have successfully eliminated the constants a and b. Okay. I hope you are understanding. Please take the screenshot of this. Please take the screenshot of this. I hope everyone has taken the screenshot of this. Let's move further now towards the main topic of the chapter. And the main topic is solutions to differential equation. Solutions to differential equation. So this is the major part of the entire chapter, and here you are going to study various methods. So the first method which you are going to study is variable separable type. The second method what you are going to study is you can reduce into variable separable. So reducing into variable separable form. Third type, okay. Third type of numericals are homogeneous differential equation. Then you have linear differential equation. I write it as LDE. Then you have Bernoulli's differential equation. Then you have exact differential equation. Then next type of numericals will be general variable separable type. And then finally we will study applications of differential equation. So there we can see heat equation, wave equation, orthogonal trajectories, a lot of things you are going to see in that. Okay, so basically the chapter is going to have this main 7 types. This is very important because in the exams when you see the numerical, we will directly not understand how to solve this numerical. So the very first thing what you have to do in your exams is after seeing the numerical, you will have to categorize into it the 7 types. At least 6 types. Once you are able to categorize the numerical into either of the 6 types, okay, then you will be able to solve. Unless and until you are able to categorize it, you will not be able to solve. Remember that. Therefore, what I have written right now is very, very important. Okay, you should be in a position to categorize. Therefore, understanding what it means is very, very, very important. Okay, please take the screenshot of this so that we can start with the numericals. Please take the screenshot. Categorizing the types is very, very, very important. I hope everyone has taken the screenshot. Okay, so I am starting with the first type. That is variable separable type. So the name itself suggests that you will be able to separate the variables and then you will be able to find out the solution. Finding the solution means what? Finding out the value of y or finding out the value of x and so on. So I've been given with an equation, differential equation dy by dx is equals to x into under root of 25 minus x square. I want to find out the solution, which means find out the value of y. Finding the solution means find out the value of y. Why like this? Because we had differentiated y with respect to x. Therefore, you will have to find out the value of y. But how you can get the value of y? We know integration of dy will give me y. Hence, you need this terms. So x will go with x. Therefore, I will get dy is equals to x into root of 25 minus x square dx. So now your y is with y and x is with x. So this is what is called as variable separable. Now x is with x and y is with y. So now you can take integration. So now I'll integrate both sides. So I'll get integration of dy is equals to integration of x into under root of 25 minus x square dx. So integration of dy will be y. And here how I can integrate, I can take the substitution. 25 minus x square is equals to t. So derivative of this will be 25 is 0. Derivative of this will be minus 2x dx is equals to dt. Therefore, I'll get x dx is equals to dt by minus 2. So instead of x dx, I can write dt upon minus 2. So my integral gets converted into integration of under root of 25 minus x square I have taken as t means it will become root of t. And instead of x dx, I can write it as minus dt by 2. So 1 by 2 will come outside. So while performing integration, okay, I'll take 1 by 2 outside. So you'll get y is equals to minus 1 by 2. I've taken outside integration of root t. Root t can be written as 1 by 2 dt. So integration of this will be y is equals to minus 1 by 2. T raised to 1 by 2 plus 1 upon 1 by 2 plus 1. So that will be 3 by 2 upon 3 by 2 plus c. So this 2 and this 2 gets cancelled. So I get y is equals to minus 1 by 3 and t was nothing but under root of, not under root. So it is raised to 3 by 2. So I can write it as under root of 25 minus x square, the whole raised to 3 plus c. So this is the required solution. So I wanted to solve this differential equation. I was given differential equation as dy by dx is equals to x into root of 25 minus x square. So solution to differential equation means finding the value of y. So after solving this, I've got the value of y as minus 1 by 3 square root of 25 minus x square, the whole raised to 3 plus c. Everyone please take the screenshot of this. I hope everyone is taking the screenshot. Continuing with the same type. Okay, continuing with the same type. Variable separable. Let's see one more numerical. So I have differential equation given as dx by dt is equals to x log x upon t. So I have to solve this, which means I have to find out the value of x in this case. So t should go with t and x should go with x. So this will become dx upon x log x is equals to 1 by t into dt. So now I have x with x and I have t with dt. So now I can do integration. Now, so this is why we call it as variable separable. So I was successfully able to separate okay x with x and t with t. Now I will do integration. Integration of 1 by x log x dx is equals to integration of 1 by t dt. Now this we have direct formula, but for x log x I will have to do substitution. So I will say put log of x is equals to u. So derivative of log x will be 1 by x dx is equals to du. What happened? 1 by x dx is equals to du. So we have this term over here 1 by x dx. So instead of this I can put du over here. So I will get I is equals to du upon instead of log of x I can put u equals to integration of 1 by t dt will be log of t plus c. So instead of c I'll write log c. See, I have to just write put integrating constant over there. But here I can see that everything is going to come in terms of log. Hence the constant also I have taken in terms of log. So integration of 1 by u du will be log of u. So I'll get log of u is equals to log of m plus n is log of m into n. So this can be written as log of c into t. So log gets cancelled on both the sides. So you'll get u is equals to ct. So we'll resubstitute the value of u. Value of u was log x. So I'll get log x is equals to ct. But I need the value of x. Therefore, I will take anti-log on both the sides and I'll get x is equals to e raised to ct. So this is the required solution to the differential equation. Okay. I wanted to find out the solution and I've got the solution. The solution to the given differential equation is x is equal to e raised to ct. So everyone, please take the screenshot of this. Got the answer? You have to taken the screenshot? Okay. Now try to understand this. We have solved two equations up till now. So what answers we have got are called as general solutions. Because we have not found out the value of C in the previous numerical also. If you are finding out the value of C, you will require some combinations of the given variable. In this case, x and t. When say t is equals to 0, x is equals to something. In the previous case, y and x were the variables. So there also requires some value of x and y so that you can find out the value of c. So if such a thing is given, then it will be called as particular solution. So for a particular solution, value of variables will be given, which will help you to find out the value of C, which is unknown in this case. Okay. So let's see such a numerical where you need to find out a particular solution. Without knowing the values of variable, you cannot find out particular solution. Remember that. So we have some numerical like this. So I have to find out the solution of the differential equation where differential equation is dy by dx is equals to e raised to 2y cos of x when x is equals to pi by 6 and y is equals to 0. So see, condition is given to you. This will help you in finding out the value of integrating constant. And hence the answer which we are going to get will be called as the particular solution. So let's solve this. So x should go with x and y should go with y. After that only you will be able to integrate. So I'll get 1 by e raised to 2y dy is equals to cos x dx. So now I can integrate. So integration of e raised to minus 2y dy is equals to integration of cos x dx. Since I've taken this denominator into numerator, I've changed the sign of the power. Now integration of e raised to 2y will be e raised to minus 2y upon minus 2 is equals to integration of cos x will be sin x plus c. So now we can find out the value because he has given that x is equals to pi by 6, y is equals to 0. So when I substitute over here, e raised to 0 is going to be 1. So e raised to 0 upon minus 2 equals to sine of pi by 6 plus c. E raised to 0 is 1, so I'll get minus 1 by 2 is equals to sine pi by 6 means 30 degree, sine 30 degree is 1 by 2 plus c. So this comes over here. Therefore, I'll get minus 1 by 2 minus 1 by 2 is equals to c. So minus 1 is 2, 2 upon 2, that will be minus 1. So I'll get the value of c as minus 1. Therefore, the required solution will become an e raised to minus 2, I'll write down. So minus 1 by 2 e raised to 2y is equals to sine of x minus 1 because value of c is minus 1. So this is the required solution. Okay, so this is the required solution of the differential equation. This type is very simple. Dx will go with x, dy will go with y. Once you've got dx with x and y, dy with y, okay, what we'll do is we'll do integration. Let's see one more. I hope everyone has taken this screenshot. Let's see one more. So this time we have given us y minus 1 upon y plus 1 plus x minus 1 upon x plus 1 into dy by dx equals to 0 at x is equals to y is equals to 2. Okay. So to find out the solution, we need to find out the value of y. The value of y can be obtained only by integrating. For integration, dy should be with y and dx should go with dx. Okay. So the thing is that is what we are going to do. So one over here, so I'll get x minus 1 upon x plus 1 dy by dx is equals to minus of y minus 1 upon y plus 1. Mm, Then I will have to swap these values now. This comes over there, this goes up. So when I do like this, so I'll get y plus 1 upon y minus 1 into dy is equals to x plus 1 minus of x plus 1 upon x minus 1 into dx. So successfully I have brought y with dy and x with dx. Okay, so now I have x with dx and y with dy. Once I get this, I will have to do integration. So we will perform the integration now. So integration of y plus 1 upon y minus 1 dy is equals to minus of integration of x plus 1 upon x minus 1 dx. So which can further be written as 2 minus 1 that will give me plus 1. So I can write this as y minus 1 plus 2 upon y minus 1 dy, and similarly here also x plus 2 minus 1 upon x minus 1 dy, which can further be written as integration of y minus 1 upon y minus 1 plus 2 upon integration 1 upon y minus 1 dy. So now I can integrate. Similarly here also integration of x minus 1 upon x minus 1 plus integration of 2 upon x minus 1 dx. So this y minus 1 gets cancelled. So integration of dy will give me y plus 2 into 1 by y will be log of y. So this will give me 2 log of y is equals to minus of here also x minus 1 gets cancelled. So integration of dx is x plus 2 outside 1 upon x minus 1, that will be log of x minus 1 plus c. So now we has given that x is equals to y is equals to 2. So to find out the value of c, I will put the value of x and y as 2 2 because it is given in the question. So 2 plus 2 log of y is equals to minus sign, I'll multiply inside. So minus 2 minus 2 log of, oh I made mistake over here, right? This is y minus 1. So here when I put 2 minus 1, that will give me log 1. Similarly here when I put value of x is equals to 2 minus 1, that will give me log of 1 plus c. Now log 1 is 0. Log 1 is 0. So from here I'll get 2 minus 2 comes over here. So minus 4 is equals to c. So I get value of c as minus 4. So I'll substitute again. And after substituting, I'll get the solution. So I'll get the solution as y plus 2 log of y minus 1 is equals to minus x minus 2 log of x minus 1 Value of c is minus 4, so this is minus 4. So this is the required solution to the given differential equation. So we had been given a differential equation something like this, y minus 1 upon y plus 1. So we have got the different solution to this as y plus 2 log y minus 1 is equals to minus x minus 2 log x minus 1 minus 4. I hope you guys have understood this. Please take the screenshot of this. Taken the screenshot. Let's see next type. Okay, reducible to variable separable. So reducible to variable separable form. So I have this 1 plus dy by dx is equals to cosec of x plus y. So now you will not be able to separate here. You can see here. You cannot separate. In the previous numericals what we have seen, we will able to separate y with dy and x with dx. Now as the angle is inside cosec, you will not be able to separate x with dx and y with dy. Okay. So what we'll do here, we'll take one substitution. So where you cannot separate, there only you will take the substitution. So I'll say let x plus y is equals to u. So on differentiating with respect to x, I'll get 1 plus dy by dx is equals to du by dx. So see here I have 1 plus dy by dx. So instead of 1 plus dy by dx, I can put du by dx. Okay. So let's solve this. So instead of 1 plus dy by dx, I will put du by dx is equals to cosec of x plus y. I am substituting it as u. So now u with du and x with dx, therefore I'll get du upon cosec of u is equals to dx. Now 1 by cosec is sine, right? 1 by sine is cosec. So 1 by cosec will be sine. So I'll get sine of u du is equals to dx. So see now I've separated u with du and x with dx. Therefore I'll do integration on both the sides. So integration of sine u du is equals to integration of dx. So I will get integration of sine is minus cos x is equals to integration of dx will be x plus c. Sorry, this here it is u. So minus cos u is equals to x plus c. So from here I'll substitute the value of u, and the value of u is x plus y. This term also I'll take over there. So I'll get x plus cos of u, that is nothing but x plus y plus c equals to 0. So this is the required solution to the differential equation. Okay, x plus cos of x plus y plus c equal to 0. Okay, I hope you have understood how we can substitute and convert the given equation into variable separable form. Take the screenshot of this. Please take the screenshot of this. I hope everyone is patiently waiting on this. Let's move on to the next numerical in the same type. So this time we have dy by dx is equals to 4x plus y plus 1 the whole square. So here also now if you do the squaring, you will get a term called as xy. So you won't be able to separate x with x and y with y. Okay, you will not be able to separate. Since you will not be able to separate, again like last time we'll do a substitution. We'll say put this entire thing 4x plus y plus 1 as say u. So derivative of 4x will be 4, derivative of y will be dy by dx, derivative of 1 will be 0, so I'll get du by dx. 4 goes over there, therefore I'll get dy by dx is equals to du by dx minus 4. So this value I'll substitute in the above equations. Instead of dy by dx, I'll write du by dx minus 4 is equals to this entire term I have put it as u. Take 4 over there. So I'll get du by dx is equals to u plus 4. So next aim will be u with u and x with x. So I'll do something like this. Therefore I'll get 1 upon u plus 4 du is equals to dx. So I was successfully able to separate x with x and u with u. The moment you are able to separate x with x and u with u, the next step is doing integration. Okay, so now next step what I'm going to do is I'm going to perform integration. So integrating both sides, integration of 1 upon u plus 4 du is equals to integration of dx. So integration of 1 by u is log, so this will give me log of u plus 4 is equals to x plus c. So we'll resubstitute the value of u and I can take antilog on both sides. Therefore, I'll get u plus 4 is equals to e raised to x plus c. We'll resubstitute the value of u. Value of u was 4x plus y plus 1. So I'll resubstitute the value as 4x plus y plus 1 is equals to e raised to x plus c. The other terms I'll take over there, so I'll get here y is equals to e raised to x plus c minus 4x minus 1. So this is the required solution to the given differential equation. Okay, I hope you have understood this. Please take the screenshot. Let's move on to the next. So next we are moving to the next type, type number 3. So type 3 is homogeneous differential equation. So what do I mean by homogeneous differential equation? So if power of all the variables is same, if power of all the variables is same, then the given differential equation will be called as homogeneous differential equation. See, for example, I have this x square y dx minus x cube plus y cube dy equals to 0. So see here also 2 plus 1. So power will be 3. Here also power is 3. Here also power is 3. So if power of each and every term is same, okay, then the given equation will be called as an homogeneous equation. Okay, let me give one more example. If I have x cube y dx minus x raised to 4 dy equals to 0, or x raised to 4y, I have this minus x raised to 4 plus x square y square plus x cube y dy is equals to 0. So again, if you see here 3 plus 1, this is going to give you 4. Here also I have 4. 2 plus 2, that will again give me 4. 3 plus 1 again give me 4. So again, power of each and every term is equal. Since the power of each and every term is equal, the given equation is an homogeneous equation. So whenever we have homogeneous equation, we do a substitution. What is that? Put y is equals to vx. So the moment you find that it is an homogeneous differential equation, so you don't have to think, you directly have to do this substitution, y is equals to vx. So when I do this substitution, y is equals to vx, so derivative with respect to x, so it will be dy by dx is equals to, keeping v as constant and taking derivative of x, so that will give me 1, plus keeping x is constant and derivative of v, that will give me dv by dx. So you will have to do this two substitution. One is, instead of y, you will have to write vx, and instead of dy by dx, you will have to write v plus x dv by dx. So whenever you find a numerical, okay, which is a homogeneous differential equation, so without even thinking, you can directly use this substitution. You even don't have to think twice. The moment you are able to understand that it was an homogeneous equation, you can directly do this substitution. So take the screenshot of this. Done. I hope everyone has taken the screenshot. Let's move to the next. So let's solve numerical of this homogeneous type. So we have x square y dx is equals to x cube plus y cube dy. Okay, so if you can see, I have already written this example. This is an homogeneous equation. So you will have to substitute the value for dy by dx. So the very first thing is find out the value of dy by dx. So dy by dx will become x square y upon x cube plus y cube. Okay, so now we will do a substitution. Put y is equals to vx and dy by dx will be nothing but v plus x into dv by dx. Sorry. So instead of dy by dx, I will put v plus x dv by dx is equals to x square. Instead of y, I will put vx upon x cube. Instead of y, I will put vx the whole cube. So that will give me x cube into v upon your x cube plus v cube x cube. So this x cube can be taken common and can be cancelled. So I will get v plus x dv by dx is equals to v upon 1 plus v cube. This v I will take over there. Therefore, I will get x dv by dx is equals to v plus upon 1 plus v cube minus v, which can further be written as x into dv by dx is equals to, when I take the LCM, so I'll get v minus v into 1 plus v cube, the whole raised to 1 plus v cube, which can further be written as x into dv by dx is equals to plus v minus v will get cancelled, v into v, that will give me v raised to 4 v raised to 4 upon 1 plus v cube. So now I can separate x with x and v with v. So I'll cross multiply and do that. So 1 plus v cube upon v raised to 4 dv is equals to dx will go up. So dx upon x. So now I was able to separate it. Once I have separated, what I'll do? The next step after separating is always integrating. So now I'll integrate both sides. I can write 1 upon v raised to 4 plus v cube upon v raised to 4 dx is equals to integration of 1 by x dx. So integration of 1 upon v raised to 4, so that will become v raised to minus 3. So v raised to minus 3 will be v raised to minus 3 plus 1. Sorry, v raised to minus 4 will go up, so that will become v raised to minus 4 plus 1. So v raised to minus 3 upon minus 3 plus this v cube and this gets cancelled. So integration of 1 by v will be log of v. Similarly, integration of 1 by x will be log of x. So constant also I'll write it as log of c. This can further be written as this terms I will take there. So I will get log of V is equals to, this is log of x plus log of c can be written as log of x into c. And this is minus, there it will go, so it will become plus. So plus 1 upon 3v cube, which can further be written as, we will have to resubstitute the value of v. So your v will be x upon, sorry, your y is equals to vx, so this will be y upon x. So when we resubstitute the values, I'll get log of I have very less space. So I'll get log of v can be written as y by x is equals to log of x into c plus v cube will be y cube by x cube. So x cube will go up. So that will become x cube by 3y cube. So this is the required solution. So this is the required solution to the given differential equation. Log of y by x is equals to log of x into c plus x cube by 3y cube. I hope things are clear to you. Let's do one more numerical on the similar type. So I have x dy by dx is equals to x tan of y by x plus y. So again, if you see because of the divisional there is one only, therefore it is a homogeneous equation. And if it is a homogeneous equation, what we do is put y is equals to vx. Therefore, your dy by dx becomes v plus x into dv by dx. So when we substitute over here, so I'll get x into dy by dx can be written as v plus x into dv by dx is equals to x into tan of y can be written as vx by x plus vx. So this x gets cancelled. I'll multiply x inside, so vx plus x square dv by dx is equals to x into tan of v plus vx. So on both the sides vx is there, so vx gets cancelled. Therefore I'll get x square dv by dx is equals to x into tan of v. 1x and this x will get cancelled. Now v with dv and x with dx will give me, so tan v will come down, so this will become 1 upon tan of v dv, this x will go down, so 1 by x dx. So now on integrating, so before integrating, tan of v, 1 by tan is cot, so this will become cot of v. So integration of cot of v dv is equals to integration of 1 by x dx. So integration of cot is log of sine. So this will be log of sine of v is equals to log of x. So integration of 1 by x is log x. So c I can take it as log c. So I can write log of sine of v is equals to log of x into c. By property of log, log of m into n can be written as log of m plus log of n. Okay, so on that basis, now log is there on both the sides, hence now log will now get cancelled. So what I'll get is sine v is equals to xc. So now I'll get sine v is equals to xc. Now we will resubstitute the value of v. V will be y upon x. So I'll get sine of y by x is equals to xc. So this is the required solution to the given differential equation. So we were given with differential equation and we have successfully solved and got the solution of the required differential equation as sine of y by x is equals to x into c. Please take the screenshot of this. So we have completed third type also. Now we'll go to the fourth type, linear differential equation. Linear differential equation. Linear, which means we know the power has to be 1. So it is going to be a single degree, okay, single order. So first order single degree equation. And therefore it is called as linear differential equation. We know if the power is 1, the equation is called as linear. So equation of the type dy by dx plus py is equals to q, or dx by dy plus px is equals to q. So equation of this type is called as linear differential equation. Okay, now what is p and q? Where p and q are function of x in this case, and here my p and q are function of y. So up till now, what we saw over simple numericals. Now, when I say function of x, so it can be any function. Okay, logarithmic, trigonometric, inverse trigonometric, algebraic. Okay, it can be exponential, any. One important thing over here is we have ready-made solution. Up till now, what we had to do, we saw so many numericals. So at the end, we had to convert, we had to find out x with x, y with y, then we had to do integration, and then we had to find out the value. So here you have ready-made solution. So you have to find out the values and substitute in that solution. So the solution to the first kind of the linear differential equation is given as, before going that, we have something called as integrating factor, IF. It is called as integrating factor. So the solution to the first type of differential equation, calling it as first type, calling it as second type. So solution to the first type of differential equation is y into integrating factor is equals to integration of q into integrating factor dx plus c. Solution to first type. So if the linear differential equation is of the first type, then its solution is given as y into integrating factor is equals to integration of q into integrating factor dx plus c. So how do you find out integrating factor? So for that also you have the formula. Integrating factor is given as e raised to integration of p dx. Okay, integrating factor is given as e raised to integration of p dx. So this is for the first type. If the equation is given in the second type, if the equation is given in the second type, then solution to that is given as x into integrating factor is equals to integration of q into integrating factor dy plus c. So things remain similar. Only what happens is instead of x we'll write y and instead of y we will write x. So this is solution to second type of linear differential equation. Okay, so I've written both the types. So again here my integrating factor will be similar integration of e raised to p dy. Okay, only difference is instead of y we'll have x. So in this case the integrating factor is given as integration of e raised to p dy. There it was integration of e raised to p dx, whereas here it is integration of e raised to integration of p dy. So this is linear differential equation. We have very less time now. Hardly I'll be able to solve any numerical in 5 minutes. So take a screenshot of this. Take a screenshot of this. So when we start the next lecture, we'll complete linear differential equation, Bernoulli's equation, okay, then exact differential equation. Then we'll see one more type, which is general variable separable, which is very, very important from JEE means point of view. And then we'll directly move on to important exam numericals. Okay. I hope you were able to understand today's class. As very less time is left, I won't be able to complete any numerical. So we'll see those are the numericals of this linear differential equation in the next class. Okay. Have a nice day ahead.
Thank you, sir.